Hey, what's up, party people? Man, got some fucking bad news. Got credit card accounts, you know how it is. Used to keep real good track of my credit card accounts and shit, and oh man, I went to go. So apparently, I signed up for like a free trial PDF website. Like it's just a PDF editor. I had to use it like literally one time. It gives you like the 7-day trial. I put it on my to-do list to cancel it. Apparently, I thought I canceled it because I took it off my list. Well, wasn't keeping up with my transactions very good on one of my credit cards and went to go check it out. Fucking charged me $200, bro, over the course of 4 months. 3.5, really. Like, couldn't believe it, dude. Couldn't believe it. They gave me a refund for the last month. Why would it be $50 a month? Like, why would it ever be? Like, I understand, like, 10, 15, maybe 20. But, bro, like, come on, man. It's like, if you don't check, something's gonna go wrong. If you check, everything will be fine. And I'm usually, like, really good about keeping up with my finances. I'm, like, very good about that. Apparently not, though, right? Like, apparently not this time. So, fuck my day up, bro. Like, damn, there went $200. You know, it's just the fact that it's wasted, you know? Like, God, I could have spent it on anything. But, yeah, anyway. Okay, so, let's do this. Life goes on. Fucking assholes, bro. What an idiot. What an idiot, eh? Why is this so loud compared to... Why is... Whoa. Okay, so it's showing that this is way louder. So it should be fine as far as the volume. God, I really don't feel like doing this second session. I should have did my second session before I did my banking. But I was like, let me do this real quick and fucked my own self over. Why does this sound so loud? Dumbass. Yeah, doofus. Okay, all right. We're in it to win it. Let's get focused and okay. So what are we doing here? We last session we were testing which is faster on conflict do update versus insert or replace. So we're gonna go and do that. We stopped at line 2 in SQLite test AI. So ChatGPT made this test for us. Let's see, ChatGPT, yeah, it stopped here. You need to determine that on conflict do update is indeed faster than insert or replace. This was generated by AI. ChatGPT need to ensure the test method does mostly replaces overwrites, since that is what our real word process would be like. Okay, so I worded that like a fucking gorilla, but nonetheless, the fact remains. We need to determine or verify rather that on conflict do update is indeed faster than insert or replace. So on conflict do update on conflict do update is indeed faster than insert or replace, because it says it would be faster in like our scenario where we're almost always going to be overwriting replacing. Therefore, like insert or replace would delete and then recreate it, as to where on conflict do update would just like update the field that needs to be updated. So yeah, I'm like pretty sure on conflict do update is going to be faster, but just to be safe, we're gonna verify that. So let's look at this code here. We got our setup for time it. Import SQLite 3 con equals SQLite 3 dot connect memory. I don't know why. Like, what is this? Memory. SQLite 3 connect memory. So it's not like actually creating a file. It's just like accessing memory directly. It's like not even storing it. It's like keeping it in RAM or something. Let's see what that's about. I've never seen that before. You know, I like to learn new syntax and stuff. Creates a new in-memory SQLite database. Memory tells SQLite to create the database entirely in RAM rather than on disk. Okay, gotcha. Temporary. The database is this only while the connection is open. Once kind of closes called or program ends, all data is lost. Since it is stored in RAM, it is faster than disk-based databases. Well, I don't want that because, like, obviously I'm gonna have I'm like, in the real world, I'm not gonna be operating from the RAM. Range 100 is a Python expression that creates a range object representing the numbers from 0 up to, but not including 100,000. 100 underscore 1,000 is just a more readable way to write 100,000 using underscores as digit separators, which Python allows since version 3.6. But you can't just do range of 100 comma 000. So you can't do range of 100,000. You cannot do range because the comma is not a valid digit separator. Python will interpret 100,000 as a tuple of two integers. 100. Oh, I didn't even think about that, dude. I didn't know that. I just learned that today. Okay, Python reads that as range of 100 to 0, same as range of 100 to 0, which causes an error because of blah blah blah. Yeah. So okay, cool. So underscore is a digit separator. Underscore is a digit separator. That's cool. Didn't know that. Learned something new. So, I really don't want to add shit to test reminders, but like I'll just add it because I feel like that's something I probably need to remember. It's like some of those basic Python operations that you need to know. So let me just write it out, and we're gonna say range of 100 underscore 000. Range equal to range of 100,000. And then yeah, that's it. And then we're just gonna say range. What is it called? Digit separator. Yeah, digit separator. So we're gonna say range underscore digit separator and the date 5/28/25, and then we're gonna have the reminder that you can use underscore as a digit separator in range, since comma is not a valid digit separator. And then we'll just write will work, and then we'll write range of 100,000 and will not work. Alright, moving on. I love that hot pink color though. Okay, so what is up with this weird? This is so AI language. Like, what is this? Create table KV. Oh, key value. Okay. Cur execute many into KV. Key value values. And this is where I get confused. Okay. Wait. Key value. And then it's got a list comprehension, and it says f string k at I init for I in range of 100,000. So the I is going to be each number, and then the value is just going to be init. Because that's strange to me. Is a valid and efficient bulk for bulk inserting 100,000 key value pairs into a table named KV. Corrects many efficiently performs many inserts using a single prepared statement. Generates a list of 100,000 tuples like K. Oh, okay. Okay, I see. K0, and then the value is just init. Okay. Wrap it in a transaction. Okay, but like... that's not going to... that's not going to replace. Let's see. Con commit. And then data equals K at I. V at I. So it creates a list comprehension again. For I in range. It's like, how does it access K without K? Like, what is K? So I know we have KV. But where is it, like... where does it get K from? I don't even want to, like, review this, but I'm just like... where does, or how does it know what K is in the context of the data equals line? The K inside is just a string literal, not a variable. Oh, right. You're using an F string. Okay, I'm tripping. Yeah, I'm an idiot. Sorry. Okay. Okay, so this is literally just creating a... this is just a data set. K0, K1, K2, K3, and then V0, V1, V2. Okay. Okay, so this is what it starts with. And then it replaces it with data, and then tests for insert or replace into KV, key value, values, placeholder data. Okay. So data itself. So it knows when you say insert or replace into key value values, it's going to basically unpack data as data is a list. It's gonna like automatically iterate through the list. So this is gonna replace all the columns or rows rather, so that well, K at I would the key would remain the same, I believe. Yeah, the key would remain the same, but the value would be changed from init to the digit V1 V0 V1 V2 V3 V4 up to 100,000, and then we commit. Okay, and then statement update, correct statement insert into key values on conflict key. So if the key already exists, which it would, because the keys are the same, we would update it and set the value equal to the excluded dot value, and then we pass data. Okay. Well, but wouldn't at this point okay, well, no, it doesn't matter if it's the same. Yeah, it's checking for the on conflict of the key. So if the key exists, it updates the value, even if like the value is the same, it still technically will update that value. Okay, so I have to ask it about that just to make sure. So let's see. This is AI big brain code here. So for the on conflict execute many call, would it actually replace the value, since the values would be identical, since we already replaced the values when we ran the insert or replace execute many? Follow what I'm saying here? Yes, you're exactly right on how you're reasoning through this. After running insert into key value, then this line sets up the new data. Right, okay, so it'd be init, gotcha. And then we have, so now data is K0, V0, K1, V1, blah, 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 blah. After insert or replace, insert replace in a key value data, replaces every row resulting in the table looking like K0, V0, right? So now when you run the second operation, each key already exists and already has the exact same value. So SQLite detects a conflict on the primary key column. The do update set value equals excluded dot value part runs. The do update set value equals excluded dot value part runs. Yes, okay. But the new value is identical to the old value, so what happens? Yes, SQLite still performs the update. Okay, so even if it's exactly the same, it doesn't like check that. It just copies it in even though it's identical. So that means it will acquire the row lock, write the same value again, incur some write costs, though it's less than a full delete plus insert as with or replace. And then, okay, gotcha. So it does, it still will write. It's not a no-op, even though the values match. So that's what they call that, a no-op? No-op. If you want to avoid unnecessary writes, you need to use a where clause. But that would probably slow it down. Okay. So this test actually is accurate. So far as I can see. So then we have time, replace, time it, statement replace, statement update, and then we only run it once because the range is 100,000, so we don't need to run it multiple times, right? because it's technically iterates 100,000 times in one function call. And then insert or replace, we would do time replace 0.4f. That's to the fourth float decimal point, right? So time replace, and then .4f seconds, and then on conflict do update time update 4f seconds. Okay, yes. So that's a valid. That's a solid test, I believe. So let's do Canasta testing, and then let's do pi SQLite test AI. Okay, so insert or replace is 0.14, and on conflict do update is 0.11. So on conflict do update is faster, which is what it said that it would be, and which seems like it makes sense that it would be faster. And that pretty much replicates what we would be doing, but on a much larger scale. We wouldn't really have 100,000 like entries. We're gonna have like 100 entries. Yeah, so we just have 100, and then here we would just do 100, and then we could like run this 100 times to make it like, or rather 1,000 times to get 100 times 1,000 is 100,000, right? Yeah, 1,000 times 100 is 100,000. Yeah, that's super simple math, right? Okay, so now we got an even lower number, despite us technically reaching the same number of like calculations. So this one on conflict is 0.07, and insert or replace is 0.09. So it's still faster. And that's how fast it is to run all. Well, that's how fast it is to run all 100, right? So time it runs the function 1,000 times, and then gets the average. Yeah, it's not an addition. It's not a compilation of the runtime. It's an average of the runtime per function call. So it only takes 0.07 seconds to do it, basically to iterate a replacement value into the database for the entirety of the database. Granted that it's going to be about 100 deep. Granted, some of them are going to be more complicated than the string like that. So, but yeah, I think overall we're just going to say on conflict do update is going to be faster. So we'll go with that. So we can just delete this file altogether. SQLite test AI. So let's get rid of that shit. All right, so now I have SQLite test. What are we doing here? Save logic, SQLite test. I can check a blob using a Python type check. Upsert method speed benchmark. Insert or replace. Select insert on conflict do update. 1.8 seconds. Select. We're gonna get rid of this one, and we're just gonna say insert or replace. Is roughly, what was it? 0.07. So we'll just say we'll do x100. Insert or replace x100, and then this x100, and this would actually be 0. This would be 0.95, so we'll say 0.095, and then this one would be 0 on conflict do update. That one was 0.77. Yeah. Okay. Yeah, so it's faster. it's a little faster. Fast enough to probably make a difference a little bit in the performance, although it's really not a big deal, but now we know. We're smarter. Okay, moving on. Begin testing. Begin going through save logic with a broad perspective. So we're just gonna copy this task description because it's the same thing that we're doing now. Where we didn't begin, we continued going through save logic with a broad perspective, modify existing code associated function calls to disable or remove certain vestigial code blocks, edit caution comments, add caution comments. It should say add caution comments. Yeah, we kind of modify. Yeah, I was using a little bit silly grammar there. Yeah, that's a little better. Okay. So let's go back over here to things to do. So finish logic for reconnect. Where were we exactly? We were in... We had reviewed this one, save DB setup function. Okay, I remember what we were doing. We were determining whether we were going to use on conflict do update, or if we were going to use the method here, which is insert or replace, because I realized that basically we can just instead of running these 3 lines and manually serializing the current time and inserting into the database, we could call the serialize and insert function, which does that for us in 1 line. So it would save us some lines there. And just in a broader sense, though, I'm looking at what this function does. And what it does, it creates a new stable save state in the database. It transfers... Okay, so this is the one that transfers the data from save data to stable and then to stable backup. So this really creates the backups, is what it does. So it gets a current time. But it not only does that, though. It does it all at once. This is the function that gets called whenever we are creating a new save checkpoint. So this would be probably the function that we would call in client, like whenever we wanted to create a new stable save state. So I remember we said we were trying to figure out the context in which we would call the save state function, and I think based on my understanding right now is that this save state function would get called inside of this function, and this is the function that would get called it would call this one, and internally stable save state function would call the save state function. Yeah, because that would need to happen first. Obviously, after we get the current time, we add that to the database. Then we would want to... well, we're not using the checkpoint ID, so we don't have to worry about that. So at that point, the next thing that would happen in this function is it would begin to create a new... it would create the backups, right? It would create the stable backup and the state. Well, they're stable and then they're stable backup, but they're actually 2 separates. So we have the save data stable, and then save data stable backup. So it's 3 altogether. And this logic ensures the proper order of operations to make sure we're properly creating those backups. So before we would create the backups, we would need the base save database, which is called savedata.db, we would need that to be saved properly, which means we would need to iterate through the master save object list, and I think what we would probably put that iteration through the save object list inside of the save state function. So I will put a comment here that says 528.25 add function call, and we'll put the function which is save state function call here, up, and then I'm gonna put a note that says add iteration through the master save object list inside of the save state function. As it is most properly placed there. At least I think that makes sense to me that we would add it there. So I will just go ahead and actually add it. We'll say self dot save state. That's the wrong one. Save state. And what do we have to pass to this function? Does it take an argument? It doesn't. It just takes self. And I always get confused about this. Can you call a method that hasn't actually been created yet? I think that you can. I think you can. So the fact that save state gets defined after this one gets defined is okay, because it goes off of whenever this function gets called, it would only execute this. At least I think it would work like that. So we don't have to pass anything to it. We just say self.saveState. We'll just add right here, move this and put below line 528.25. Always add your date, because you're going to be like, when did I add this? What is this from? Just trust me. Below line, and make sure you put in like what line you're talking about. Below line. Add iteration to the master state object inside the save state function is most properly placed there. Yeah, so save state is going to, we'll go over here, and need to determine at what point in the context of the above save function this function will be called. Well, we just figured that out. At least I think we did. We need to go through each function, think about the overall structure of these function calls from the perspective of client Pi to figure this out. Ensure we are not being confused about order of operation, boots on the ground logic, etc. First pass save function. Okay. So I don't think that I'm confused about like how this works. So let's go up here and let me look at this. Did I put that this one needs to be called? Since we'll be using it, when keeping it around. No, I didn't put that. I need to add this. I'll put below function. We're going to be using checkpoint ID because we're only keeping it around just in case we end up using. And this is like a process. What would we call this sort of comment? This is like a comment that is intended like a to-do comment. So we'll say save system to-do comment. I don't really know exactly how we should designate that. I guess that's fine. And then we'll just say this is the function that would get called at the beginning of the main while loop to which will internally call save state, and will also create the backups for the purpose. Oh, we'll also create the backups. We don't need to explain why. That's pretty self-explanatory. Okay, so we get the current time. We can go ahead and replace this with the serialize and insert function. So let's copy this right here, because we need to pass in the object name and the data. So right here, we would do like this. This is how I usually like to add in code that replaces other code. Say below 3 lines, 1, 2, 3. So we space that out. Now this is going to be replaced by this. Well, we have the current time first, and then we have the serialize and insert function, and this is actually self.serialize and insert function. We don't pass in self. That is explicitly or implicitly passed. Then we have object name data. So this needs to be the object name would be the string timestamp last saved. So let's copy that, put that in the object name, and then the data would be the current time. So we just copy current time, place that right there, and now we can comment this out, and we'll just say being below 3 lines, being replaced by above line, leaving until 100% sure replacement is valid. Alright. Was all caps necessary? Probably not. That's okay though. So let's just verify what happens here. We call stable save state function. We get the current timestamp. Then we call self serialize and insert function, and we pass in the object name, which is the string timestamp last saved, and then we pass in the current time for the data parameter. And what that does internally is it serializes the data by pickle dumping the current time, which is that timestamp, and then we do self cursor execute insert into the saved data, and self cursor is going to refer to the cursor which is set up in this function, the save db function, which is self.db save data.db blah blah blah. So moving forward, we have it's serialized and it gets inserted into it, and on conflict it would replace it, and it passes in the object name, the serialized data for the value, and then upon conflict of the object name, meaning if there's already a timestamp last save object name in the save data database table rather, then it would replace it with the value, which is the serialized data. So yeah, that's pretty straightforward. I think that would work. I don't like the bagpipes. It's a little too much. Alright, and let's see here. So serialized data pickle dumps data, must serialized data, yeah. It's into value, and then okay, so I think this will work. Oh yeah, and I forgot to put a note here that says we'll just put below line 52825 verified that this upsert method is the fastest via testing. Do not change to insert or replace, because that is slower. Okay, cool. What else? Verify this upsert method is the fastest via testing. Do not change to insert or replace because that is slower. This gets the double stamp of approval. And now, so yeah, that should work. Timestamp last saved, current time. So what it's replacing is the exact same thing, but just written out explicitly, where we have the serialized current time equals pickle dumps current time, and then the self cursor execute insert or replace. It does the same exact thing. The only difference is that it uses insert or replace into, and we're just going to delete these lines because I already know they're exactly like the same. So this is going to clean it up, and that's the new form of the function. Add iteration through master save object list inside of the save state function as it is most properly placed there. Okay, so this needs to be copied and placed above the save state function. So you see there's a little bit of like a this needs to be a caution comment to make sure that we take care of it. And we're going to go ahead and replace these 3 lines as well with the same thing we just did here with serialize. Well, yeah, we can go ahead and replace it, and so we can get rid of this, and this will be changed to just be below line, and we'll paste this in self-serialize. But the difference here is going to be the checkpoint ID, so we'll just pass that in there. And then the value itself would be the checkpoint ID because it gets serialized through this function. So it would always be none in this case, but we're going to comment it out, and now we would get rid of this because it would get saved as the checkpoint ID, and then the object name was indeed checkpoint ID, and then it just serializes that. So now we can get rid of that. Boom. And there, look how much cleaner that is. Self-save state. There we go. And I need to below line 528.25 ensure that this is properly executed in the context of this function. Review everything since we just added the call here and didn't actually finish creating / finalizing the save state function. Yes. Alright, we got 25 minutes left. Do I want to keep going? Not really. I really don't. I really don't. But I guess I will. I guess I'll continue. Okay. I'll try to go as far as I can, right? So what we got going on here? Self-save state. Temperature disabled, blah, blah, blah. Alright, so this all is reviewed. What we need to do now, wasn't there something I wanted to take care of that was... I feel like there was something I'm forgetting. Determine this since we're not using this function until we have finished and tested the 1x per system. Therefore, comment out all function causes this function. Definitely do not delete this as it was thoroughly created. Yes, that's true. We're going to be using checkpoint ID, keeping it around just in case we end up using it. Okay. This is the function that would get called at the beginning of the main while loop, which really. So this needs to be added. That function call in client pi needs to be added. So let's go back over to things to do and make sure, let's see, stable save state function. So that's the one that's going to get called. And let's make sure we're doing this correctly. Adds code which sets as smart logic to only save data has been changed. Finish logic for reconnect. So this is going to be a new task. We'll put add stable save state function call in client pi. API? No, not API. 528.25, baby. And what are we doing here? Need to add this function call at the beginning of the main while loop. Since this is what internally calls the save state function, and then put it also internally handles creation / update of the backup DB files. True. Very good, very good. Why is my nose itching like this? Motherfuckers. These little mites, little dust mites bothering me. They do that sometimes. I have a dust mite allergy. Grass mite, dust mites, whatever. It also internally handles creation update of the backup DB files. Okay, that does need to be done. Of course it does. That will be done at a point in time in the near future, but right now we're going to stay on task here. I know it got a little ugly with these caution comments, but they'll go away in time. It's okay. You can't let them give you anxiety like that. So let's go and review the save state function now, because that's really what we need. Why do we have load state first? I don't like looking at load state first. I'm going to... So we already have... Oh, this load state was created by... This was created by AI, and I think I modified it. It's going to have to be changed, though. Yeah, add iteration to the master save object list. Well, actually... For object name logging, cursor execute, globals. Yeah, would you need to load the data points in particular order? Yes, we would. I would just put a comment at the top of the function. So let's copy this whole thing, because I want save state to be before load state. Does that make sense? So now we have load state. Let me make sure this is aligned correctly. Yeah, okay. So now we're going to add in the comment here, which says below function 528.25. And this is a to-do. How did we structure like this? To-do comment. So I'm just going to copy this. What do we call that? We're snippet. Copy that snippet and paste it in here. Save system to-do comment. Need to go through this file and refactor it to be in accord with the new system, which iterates through well, it doesn't actually iterate through that list on loading, but it which loads in certain data in a certain way, and we'll just put these details are documented inside of save logic dot master save object list. Refer to each associated object name for description. Will not be using globals to assign values. I don't think we will anyway. Anyway, I don't think we will be doing that. Okay, so we have these are documented inside of save logic, master save object list, refer to each associated object name for description, blah 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 blah. Okay. I don't like all these caution comments. They give me the ick. I don't like seeing them. They go away in time, but okay. Back to the save state finally. All right, so we have add iteration through the master save object list inside of function as is most properly placed there. Okay, so that is actually gonna be a to-do comment as well. So I want to make sure we're using. I just hit some forbidden combination on my keyboard just then. Where are we at here? Below function, add iteration through. Yeah, right here, baby. Right here, baby. Okay, below function, save system, to do, comment, add iteration through the master save object list. It's most properly placed there. What else do we need to do? Well, we need to go through and review the entire function to ensure it's in accord with being called in the context of the stable save state function. Man, I'm on point right now. Let's review function in light of it being called from within the stable save state function. If only I could type. If only I could type properly and my keyboard didn't like fucking slide all over the place like I greased my computer desk with some baby Earl. Okay, save system review function in light of it being called from within the stable. Okay, that's pretty straightforward, and yeah, that's it. I think like that pretty much encompasses what we have to do, right? So let's see. First pass save state function to be run once per minute. Saves all necessary data to. Yeah, first pass save state function to be run once per minute. Saves all necessary data to database. Review the item. So we actually need to make final pass through it and then review. So that would be the next thing. So we'll say first we can add the iteration, then we're going to add logic, which is documented in master save object list to handle each particular object name or just data point that is saved. Add logic, comma, which is documented in message. Comma to handle each. Yes, there we go. Okay. And review function in light of being called. First pass save state. So now this is not the first pass. Now this will be second pass. Right? So we say with SQLite 3 connect DB path as con. Is that correct? Because now we're going a line, doing a line by line review. And honestly, where is it? Stable save state. That's the one we need to compare it with. Okay, so in this function, well, it's a string of functions. So it's a string of function calls. We have saveDB, which creates self-db. Okay, so self.db is the save data database. So self cursor is self.db's cursor. So we would want to operate on the self cursor because we already have technically this database is already open and connected to. Yeah. I mean, theoretically, we would have connected to it early. Like, we don't need to connect to it until we're about to use it. So, should we modify this? Like, I don't know. Is that an issue? Like, if we already have a connection, well, you can create another connection to it, right? Like, it doesn't really interfere with it. And it still goes to the same, like, table. It still goes to the same database. It's not gonna mess anything up, per se, to have multiple connections. I think multiple connections, I forget how that works. Multiple connection versus multiple cursors. I don't want to rush through that. I don't want to nitpick at this either, though, because this might, like, I know that we do the connection because we do some, like, operations on it early on at the very beginning of the game. Maybe before we would be calling, like, setting up a connection in the context of this function. So I'll just go ahead and say, like, we'll use right now, we'll just go with, like, since it's kind of up in the air what the final format is going to be, we'll just say that we'll probably use the existing cursor, which uses the existing connection that's created here. So we would use self-db, but actually we would just use self-cursor because cursor is connected to self-db. So we would just say self-cursor instead, because that is an instance object. So let's see. Instead of doing with SQLite 3 connect db path as con, well, actually it says we're supposed to close the connection because it's basically wasted resources. With SQLite 3 connect, let me just ask real quick. Can you have multiple connections to the same, can you have multiple connections to the same DB file in the same script simultaneously? I'm pretty sure you can. I just forgot how that worked. I know if you have two different cursors, it behaves differently. So yes, you can have multiple connections to the same SQLite database file in the same script simultaneously, but there are important caveats and best practices to keep in mind. So import SQLite 3 con1, and then we have con2. Now con1 and con2 are independent connections to the same file. Concurrency and locking. SQLite uses file-based locking, so reads from multiple connections are fine. Okay, so you use multiple connections if you wanted to use concurrent reads. So if I wanted to have multi-threading and concurrently access the same database file through two different connections, we could do that. But we're not multi-threaded, so like I don't think that would even pertain to our system on the client side. Writes are serialized. So reads from multiple connections are fine. Concurrent reads are allowed. Let's see. Reads from multiple connections are fine. Concurrent reads are writes are serialized. What does that mean? Writes are serialized. Only one connection can write at a time. If two connections try to write simultaneously, the second will block or fail with a SQLite 3 operation or database is locked unless handled. So yeah, I think we should, pretty sure we should be fine, like, because we don't have concurrency going on anyway. So use wall mode write-ahead logging to improve concurrency. Enables concurrent reads while writing. Still only one writer at a time. Commit or close connections as soon as possible to reduce locking. Avoid long transactions if using multiple writers. If using threads, set check same thread equal false. Yeah, we're not doing that. Example multiple connection. Yeah, so we have to set up the pragma for each connection. It doesn't carry over, so that is an important point. So, yeah, we're just gonna go ahead and say we'll create a new connection for the sake of like. We can always come back and modify that. It's not a big deal. It's not like do or die, you know? So we're basically gonna like well, we don't have to refer to it in the context of self-db, do we? I don't think that's necessarily the way we have to do it. Gotta make sure I'm doing it right though here. I don't want there to be any conflicts. But if we did self-db equals SQLite3 connect in the context of that function call, it would just override this one. So like, it would basically, there would still be that initial connection, but it would just like, it would be live in the background, which is like not good. We don't want to do that because that's just a waste of resources. So we would probably just refer to it in the context of like without using self dot in the function that we're going to be dealing with, which is the save logic. So that means we would create the table if it doesn't exist, right? Yeah, I think we would want to do that. So we have the SQLite3 connect, save data DB, isolation level none, and then so this would create the data file if it doesn't exist. Then we have the cursor creation, the pragma settings setup, and then the cursor execute create table, so it creates table if it doesn't exist. So we definitely need to do the we definitely need to do the connect because we have to create the connection. We definitely have to do the cursor. We definitely have to do the pragma. Do we have to do the create table if not exists? Well, if we already ran this function, it's still the same table, right? Like, two cons will still access the same tables, right? Yes, two connections same will access the same underlying tables. Right. That was a stupid question. I already knew the answer to that. What do we need to do here? Self-db, self-cursor, cursor execute, blah, 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 blah. So create table. I mean, since this is another thing, it doesn't really, like, it's not going to harm us. So we'll just add it. So we'll just go ahead and basically duplicate the code in that function. Let's paste it. It's probably going to butcher the indentation, which it did by one space. Look at that. One space. No, it didn't. It messed all these up by one space. What a weird thing. Okay, so now we have self-db, but we're not going to replace it. We're just going to do db, and then we're going to do cursor, and then cursor execute. So we just have a local cursor, even though we're operating in the context of self. We're not operating on self-db. So I will add a comment here to note that. And all these caution comments, they're going to go away, remember? They're important. And this would be a to-do comment as well. We're going to say ensure that we review final form of DB reference i.e. if we will use the self.db or if we'll use local DB, separate connection. Do at the end of the function review process. At the very end. Okay, so what do we need to do here? DB cursor, cursor execute, and then we have self cursor. We don't want to do that, so we'll keep our div. And then we have with SQLite 3 connect DB path. So instead of this, we would just do oh, okay, this already handles it. So we don't actually have to write this out, and it internally creates the cursor. And don't we use the save data DB path as a self? Save data stable path. So we don't actually save the base path for whatever reason. I don't know why, but we don't. Okay, that's fine. So we'll just pass the path in explicitly like this. There we go. Okay, I think we're good here. Remember the global returns? Yeah, so I think we're gonna stop right here. It's time. 5:28:25 stops here. Cool. So this is line 259 in save logic. Let's copy this. Go over to the second tab group. Go to devlog. And we'll put this and at line number 259 in save logic.py. There we go. Beautiful. Alrighty then. And so we're at 7:05. doesn't fucking matter. Alright, so now we need to cd change directory out to the root of the project directory, which we did. So now we're at the root. We can do git branch to see if we're on the right branch, which is the new feature branch. So we are on the correct branch. We're going to do git add dot to go ahead and stage all of the files, and then we're going to git commit dash m double quote paste in the devlog double quote to close it out, and then enter to go ahead and submit that commit. We did 6 files changed, 69 insertions, 92 deletions, and we deleted that SQLite test AI file. So we're going to git push to push up to the cloud to the GitHub remote repository, and there we go. Now we can exit out of this wonderful, beautiful progress project that we finally have. Like we're getting there, right? We already made a backup earlier today, so we don't need to change the date of that. We don't need to enter into that. We just need to copy that folder and then delete this folder, which has the old data. Paste in the new data into the backup folder. Go to text, devlog, go all the way to the end, and then bam, there we go. That is indeed up to date. So now we have a local backup and a remote backup, and looks like that's going to be it for today. We did great. Very, very, very awesome session. One of the better sessions that I've had in a long time. Honestly, got a lot done. Ooh, catching a Charlie horse. That means I need potassium or protein or something. Anyway, great progress. We're getting really close to being done. I feel like everything is coming together without issues, which is good. That means I thought everything through the first time around or before implementation. I don't feel like I'm gonna have to come back and like fucking rework anything, you know, because I feel like I actually did it right the first time, or whatever time this is. So yeah, good progress. What we need to do next session is we're going to implement the save state function based on the master save object list logic, which like it's already, the work is already done. We just have to basically like write it, you know. We have to convert it from pseudocode comment to actual code in save logic. It's going to be pretty easy. I'll probably be able to finish it in 1 or 2 sessions, and yeah, then we can move on to the load state function, and that's going to be another 1 or 2 sessions. Just like I said, I was pretty accurate. I think I actually did it faster than I thought. So yeah, next session is going to be save state function. Session after that is going to be load state function, and then after that it's going to be like the other minor details to like call the functions and shit, and then we're going to test it. So you're looking at 1, 2, 3, basically 3 more sessions, maybe 4, before we actually do testing. So I'm going to go ahead and say 4 more sessions and then testing, which is like 5 hours of work. So yeah, pretty good. Hopefully we finish that like by the end of the week for sure. We should be able to knock that out. So very exciting, and yeah. All right, well, have a good evening, and I'll see you hopefully